wanted to make some videos about solving systems of linear equations. And not that there isn't a billion of them already out there. I told my students I'd do it, so I do it. Let's pick a simple example. Here's an equation. It's a relationship between two variables. You could think of it as a question. When is x plus y equals 2? Well, one answer to this could be 1 and 1, because 1 plus 1 equals 2. Cool. Or you could do 2 and 0, because 2 plus 0 equals 2. Great, that's another good answer. Or you could do them this way. And it turns out that the infinite number of answers to this question, each in the form of a ordered pair, which we could choose to graph if we like, fall on a straight line. This happens when the x and the y have no exponents. So imagine this question being kind of, the answers are on a line if we visualize it. So instead of interpreting this as a question, you could just say, this is a line. A straight line in 2D space. Now here is another statement. And it's a different one. I changed that. And this is a different line. Well, I could say it's a different question, because I could do, let's see, excuse me, 3 and 1. 3 minus 1 equals 2. That's a solution to this one, but it doesn't work over here. 3 plus 1 is not equal to 2. Okay? And I could ask you, is there an answer that works for both questions at the same time? And that's what I mean by big squiggly bracket. And I could sit here and guess all day. It turns out, just by eyeballing it, 2 plus 0 is 2, and 2 minus 0 is 2. That's an answer that works for both at the same time. And that's the only answer that works for both at the same time. Why would I think that it's the only one? Well, because if this is a straight line, boop, and this is a straight line, boop, well, they can only cross in one spot. Either they're parallel and don't cross, they're actually the same question or line, or they cross in one spot. Now, what if it's not so easy that you could just eyeball it? Let's pretend like I couldn't do that. You know, here's what it, see, this is what they actually look like. Use your Desmos. It's a super useful tool. You can see right here, 2, 0, boom. But what I want to do is answer both these questions at the same time. Infinite number of answers, infinite number of answers. It'd be cool if I could combine these two questions to make a new question that only had one answer. And there's two ways of doing that. You can either add them together, which is the addition method, or you can substitute one equation into the other. Substitute. Right? Either way, your goal is to eliminate a variable. All right, by doing this. And this one's super duper easy because these are equal and opposite. It's obvious that if I added one equation to the other, x plus x is 2x, y minus y, 0 y's, 2 plus 2 is 4, and hopefully you could look at that and go, obviously x equals 2. Okay, well, this is half the answer. Where do these lines cross? Well, wherever they do cross, the x coordinate is 2. So we know this, 1, 2, here is a dotted line that represents all the possible points that where x is equal to 2. So what we know is that these lines cross somewhere here. We just need the y value. Well, it doesn't matter which one we pick either one. X is now 2. That's the one that makes both of these true. Okay? So you can imagine that's now known. It's known to be 2. Okay? And since we're looking for the point, the coordinate, well, the y value, where both of these are true, it doesn't matter which one we plug it into, right? Wherever they cross, the y value for this line is the same as the y value of this line at that point. So that's what we're going to do. Now it's kind of hard to have like good notation. If you're going to write your math and write it nicely where somebody can follow your train of thoughts, these types of problems are kind of, it's kind of hard to find a way to nicely write, because we did this, and I could follow that, top to bottom, left to right, and now I say, okay, so in this case we did addition method, and when we say these methods, we're talking about the method we're using to find the first variable, right, for first variable. Because after that, we always use the substitution method for the second variable, because we're substituting 2 in for x, okay? So plug it into either one, and I could say here, plug into either one, but I hate writing. I could say, okay, since x equals 2, therefore, replace x with 2. We know this, and we know this, just by taking the 2, putting it there. But I'm not going to give you scribbles. This is something I want to turn in and look nice. Somebody's going to read it without hearing my voice. And of course, we didn't need both of these. Just one would have worked, you know. But here you can see, subtract 2 from both sides. Subtract 2 from both sides. Either way, you get the same result. So the answer is that. No, lines cross at a coordinate, and a coordinate is a point, and a coordinate needs to be written like this. Right? The answer, the data structure of the answer is a coordinate. So we need to give the answer in coordinate form. So let's go ahead and put that. That's my final answer. This is the work I did. Now that's the addition method. It's always going to be quicker. Now let's look at substitution method instead. Substitution method, yeah. Oh yeah. Okay, so what did our problem look like? It was x plus y equals 2, x minus y equals 2. Okay, so to eliminate one of the variables, we're going to substitute one equation into the other to make a third equation that only has one variable in it. Just like we did here. We added them. That got a new equation that was a combination of those two. Because there's information here, information here. We took some of the information here and here, put them together to make a new question by adding. But this time, we're not going to do that. We're going to substitute. This is a relationship between x and y, and this is a relationship between x and y. This guy can be rewritten. It's equivalent to saying y equals 2 minus x. All I did was subtract the x. And because this is the same as this, and this has a y in it, and this is now telling me y can be substituted for 2 minus x, okay. Let's just take this guy here and boop, replace the y. And then that gives us how can I say this? That and that, I'm saying this equation and this equation now tell me with their powers combined. I'm trying to use some kind of like notation that's logical and consistent. Those two combined via substitution replace the y with 2 minus x. So I have x minus, and then a 2 minus x, and then I have equals 2. Now, that is not what you want to write down. Too many of y'all make this mistake. If you're not interpreting the symbols, and you just replace this symbol with that symbol without thinking about their meaning, this is incorrect. Remember, this is a number. It's a quantity. So you have x minus a number, right, equals 2. Let's get rid of the y and write it like that. Well, that number could be, it's a quantity, it's an amount. And this could be, here, this is called y, it's called 2 minus x, it could be called Barbara, okay? Whatever the name is, whether the pen strokes overlap or not, this is the name. And if you're going to subtract that amount, all right, you need to subtract the whole amount. Right here, we're only subtracting the 2. That's not good. We need to have that. That's the mistake y'all always make, no matter how many times I tell you. Okay? See, here, these pen strokes don't cross, but ba isn't a person, right? Barbara is. This is the name of the amount. Well, this is also the name of a different amount. And so is this. And so is this. Those are all names of different quantities. This is the quantity we need to subtract. Okay? And so because we are subtracting or adding a negative, if you will, it has more than one term. We need to have this minus sign. Here's what's going on. We're really multiplying this by a minus 1. Okay? We don't put that there because the parentheses imply it. Okay? That's what we need to do. We need to, I guess I should be even more thorough here, because I don't want y'all like memorizing and getting this one thing right. We are adding a negative this much. Okay? That's what we're doing. We don't write the 1 because it doesn't change the value. We don't put the multiplication because it's implied by the parentheses. But that's the hidden structure that we hide. Okay? We have an amount and we're adding a negative this much. And we need these parentheses. We have to have them when we're mixing operations. Let me be even more clear. We're adding a negative x. Remember, we don't need subtraction. It's just multiplication and addition. We have an amount, and we're adding a negative this much. How much is this? Well, we have 2, and then we're going to add a negative this many. Okay? So our two operations, both of them, the only two we need are showing up. And when they both show up in an expression, we don't know what order to do it, and that's when you need parentheses. Whenever both multiplication and addition are present. Even if we didn't show it, like you might not see it, but there is a multiplication here. It's a minus 1 times this. And we hid the addition too, we subtracted, but we're really adding a negative quantity. And I tell you over and over and over again, it doesn't seem to stick. Don't memorize it. Okay? So we replaced y with a different name. That's all it is. and this name only has x in it instead of y. So what happened? We combined two questions to make a new question, and it got rid of the letter y. Yeah, there's only x's here. See that? Cool. Well, great. Distribute the minus sign. Oh man. Now you don't need FOIL or anything else when you have parentheses. Look, 2 plus 3 times 4. Okay, well, if you don't know which one to do first, right? I mean, we know that we multiply first, all right? But why? Why do we know we do that? Because we memorized it, or the PIMDAS thing? What does multiply mean? What does that mean? By definition, this is 3 fours. That's what that means, right? Because all you need is addition, really. So get rid of this guy and write what it means. 3 fours. Okay? So why do we multiply first? Because it's repetitive addition. That's why we invented it. So translate it back to addition, and then there's no question about it. We need to translate to a single language of addition, where it's simple. And that needs to happen first, because addition is more primal than multiplication. That's where we started, with just addition. Okay? So you don't need to memorize orders of operations if you're thinking about what the symbols mean. Multiplying is just shortcut for repetitive addition. Turn everything into addition. Now it's super easy, right? Okay, so yeah, 2 plus 3 times 4. Do I mean this? Well, if I don't put any parentheses, that's what I mean. Do that first, because I can just turn this into addition like I did a second ago. But if I don't mean that, that's not what I mean, because that's what comes naturally. If I wanted this instead, I'd have to say this instead. Okay? Because what's that? Oh, here we go. 2. Again, what I had a while ago, translate the 3 fours. That's what it is naturally, putting it in a uniform language. Whereas this, what does times 4 mean? It means this many 4s, right? Well, let's see. 2 plus 3 is 5 4s. So this would be 1, 3, and another one, right? These are not the same. But if you don't put parentheses, we're going to do this automatically. And if you don't mean, put everything to plus signs first, and you want these to happen first, that's when you need parentheses. So when you have parentheses, it's just a distributive property, y'all. So if I have 2 times 1 plus 2, there's really a multiplication. Yeah, you know that this is 2 times 3. But, which is 6. What if I have 2 times a plus b? Because you don't know how many these are worth, you're like, you don't know what to do. You can't combine these symbols. Well, we never had to turn that into 3 in the first place. This is just another name for this much, right? So this is the same as distribute. The thing that's multiplying, distribute to everything inside. I have 2 1s and I have 2 2s, right? I'm doubling this much, okay? Well, I can do that by doubling that much, or I can double this much and, that's the word and, And I could double this much. It's the same result. Okay? Think about it like this. This is just one tally mark and two tally marks. I want to double this many. Well, I can double that, and I could double that. Or I could double that much. Either way, you have the same amount, right? Okay. If you think about it, get past the symbols. If you have to go all the way back to these little tally marks, translate it back to that. Translate it back to your fingers. Go for it. All right, where were we? Substitution. Let's see here. Oh, 2 letters. Rewrite y as 2 minus x. So I just took this y and replaced it with 2 minus x. Distribute the minus because there's really a minus 1 and we're multiplying. So distribute the minus there. Please learn to do that. So we distribute the minus to the 2. Distribute the minus to the other thing. Oops. Minus minus makes a plus. Okay. Now, that is, see, this is equivalent to this because all I did was distribute the minus and got rid of the parentheses. An x and an x, there's 2 of them now. We still got a minus 2. Okay, now, look at all this. I could do this 2 ways. Add 2 to both sides or divide everything by 2. However you want to do it. I can look at this and make all the terms half as much. And I should have put this, how do I move you down here? Cool. If I make all the terms half as much, I would have, I mean, this is not official notation, but it should be. Y'all know what I mean. I'm dividing everything by 2. 2x over 2 is x, minus 2 over 2 is minus 1, and then 2 over 2 is 1. That's the same thing as saying add 1 to both sides. There we go. Now we just have the first coordinate. Now compare that to this guy. Add them together. The y's immediately go away. And then x equals 2. You can just look at it and go, if I add these, I'll get 2 of those and 4. And just eyeballing it, you should be able to do that in your head. Here's substitution method. It's hard to do in your head. And if I'm looking at this, and I'd have to, in my mind, picture the y being the 2 and the minus x, and then putting it in there, and then in my mind, making sure I distribute this minus sign properly without screwing that up, and then simplifying in my head, because I would be there trying to get that into this. That's a lot of steps to do the same thing. The more steps, the more mistakes that can be made. Okay? So every time at this level, two equations, 2 unknowns, it's always going to be faster to do addition method. And we're still not done. But the rest of the problem is just like this one. Once you have this, you plug it into either equation to get your y value. And we already did that. But to show you how we would write it out, I'd say, so this was one thing. I got one of them. Now what would I say for the reader? I could say, all right, substituting, whatever, substituting x equals 2, gives, I kind of have to put some English here, maybe. And again, I don't need to plug into both of these. Pick one. If I was going to pick one out of one of these, I would pick this one because it doesn't have a minus sign. So replace x with 2. Okay. Gives that, and that is the same thing as saying, because I'm subtracting 2 from both sides. Okay. Now you can do this stuff. I don't like that because it's obvious what you did, right? This is your scratch work. You don't see this kind of stuff in textbooks as they're explaining it, as they're telling you like a mathematical theorem, right? Yeah, don't do that. That's for you. That's what went on in your head. I don't need to read that. If you wanted to tell me that about that step, you would write it like this. You'd say, well, this is equivalent to subtract 2 from both sides of the equation. And that is equivalent to, well, 2 minus 2 is 0. 2 minus 2 is 0. You know, if you really want to write that simple step in non-scratch work notation, this is what you're really doing. You're subtracting 2 from both sides, and that's how you really write it. But if it's just for your head, that's great scratch work. I don't want to see your scratch work. So once you have your x and your y, you say, here's my x and here's my y. This is my final answer. That's the point where the lines cross. But this is a super trivial example. Okay? But again, you can see it's easier to do with the addition method. Now, once you write it all out step by step, if you're trying to master this topic, you're not just trying to get the grade. Yes, I want to see on the quiz you write, I'm going to test not just your ability to get the answer, but your ability to write out your train of thought. That's part of what the quiz is for me, because it's the only time I get to grade such a thing. But for you, you're trying to master this language. And I don't want you to just do it this way, because to master the language, I want you to do it cognitively too. Once you're done writing out every single step, I want you to look at it and ask yourself, could you have done this in your head? Can you get the answer to this without writing any steps? Well, I can just, I can look at this and I can think, if I added these together, I would get 2x and 4. And in my head, I can think 2x equals 4. And in my mind, I can go straight to x equals 2. And now that I have x equals 2 in my head, I'm like, yeah, it's got to be 2. And I'm looking at these on my paper, and I think, imagining that, I can do that. That's not too hard to do. And with that, I can definitely go y equals 0. I could take the 2 away from both sides, and in my head, get that. At the beginning of this video, that's what I did. That's how I got the answer without doing any work. I could just look at it. And if you practice this, you can too, because this is super easy. Okay? But we're not done. All right? If this is a quiz and you want to get the right answer, it's so many steps. It's really easy to have a bad day and not be able to think clearly. So, is this correct? Right? We learn from our mistakes. Okay, to do that, first you need to know if you made a mistake or not. And you don't want to wait a week or two for me to grade it and give you my assessment. No. If this is the answer to both of these questions, then it should be the answer to this question and this question. So here were the questions. Okay. Is it correct? Well, replace the x's and the y's with their new names. Okay. Let's see. I replace x with a 2 and the y with a 0. Is this true? Yes. 2 equals 2. What about here? X and y. 2 minus 0. Is that true? Yes, that's true. Now you turn your quiz in. Way too many of y'all just kind of randomly throw stuff around and you don't know if it's right or not, and you just hope it is, and you just turn it in. Check your work. And here's the cool thing, the critical thing. Some of y'all finally get to where you check your work, right? You'll finally start doing it. You learn how to do it, you start doing it, but you only do it at the end of the problem. You can do this after every step, not just at the end of the problem. And then when you start practicing this, after every step of your math, you realize it's kind of like computer programming. Every line of code you write, you rethink it through to make sure it's doing what you want it to do. And when you do this all the time, then it becomes natural and unconscious. You just do it automatically. Whatever. Okay? You do it automatically without trying, without thinking. It's just built in. And when I say check after every step, that means you are actually interpreting what the symbols mean and making sure that the meaning makes perfect sense to you. That's what y'all are not doing at all. That's what you need to do. All right? So that was one problem. I guess I'll stop this and make another video next, because this one is super duper easy. So on the next video, we will do, I don't know, if I wanted to master this topic on my own, I wouldn't have to like look around for problems. Every single problem, if there's two variables and two equations, there's a number and a number and the number, and then pick any number, and pick any number. So there's, all I have to do is pick 6 random numbers and I get a new problem, right? Well, the difference is what makes these problems different? The different choices of numbers. Well, y'all might be able to do this easy one, but then you might have problems with the fractions. If I gave you a problem like this, 1/2 y, I don't know, 3, and blah blah blah. You might be like, oh, the fractions are hard. Okay, well, invent a problem with fractions and do that one. That's what I'll do for you next. Okay, and then what if the fractions aren't the same? Oh, that's a different problem, right? Oh, now these aren't they don't have the common denominators. Now okay, and then, well, what if both problems have fractions instead of just one of the equations, right? Well, that's a different problem for y'all, right? There's a different issue, right? So instead of one fraction, there's 2 fractions, and now instead of one equation with fractions, both of them have fractions. For y'all, that's a different problem. And then what if the numbers, the coefficients, are irrational? Something like that. These are numbers. Those are the names of them. They're fixed quantities. They're not ratios of whole numbers. They're simply not. And then this is a whole different challenge for y'all, right? But every single problem you can do, if there's 2 variables, if they don't have exponents, this is going to be a line. So this is a straight line, this is a straight line. Once you tell me the A's and the B's and the C's, I know exactly which 2 lines. But in the meantime, think about trying to solve that. That is the answer to all the possible questions I can ask you if there's 2 variables. Okay? And this is algebra, right? All of these separately, pre-algebra. But look at our answer here. Think about it like this. We kept simplifying, right? What is the answer to this? We said 2, right? Well, that's because I kind of skipped some stuff. Check it out. I really, let's see, where did I get 4 from? When I combined those, I did some extra stuff here. Check this out. Here's what's going on. Here's an insight. X plus y equals 2. X minus y equals 2. So with the addition method, we get x plus x equals 2 plus 2. Okay, and then we simplified that, right, to 2x. How about I leave this the way it is? Because that's the symbols that are here. I'm just going to leave them together. Okay? And then, so that, if I add them, I get that, which is the same as that. And then I got dividing both sides by 2. Okay? Yes, that's the same thing as 4 divided by 2 is 2, but notice this is the same as that. And when we don't hide the structure, right? Actually, let me, instead of using that, I'm going to do this. Instead of dividing by 2, we're going to multiply by half, okay? Instead of division. We don't need division, right? We're going to multiply by a half. 2 operations, plus and times. So the answer is a combination, using the only 2 things we can do, add and multiply, of the values. And again, there's really a 1 here, and a 1 there, and a 1 here, and a 1 there. We hide those. So the answer is a combination of these 6 symbols stuck together using addition and multiplication. That's the answer. That's the name of it. We can simplify it to this, but that's the name of it. Now, what is the y value? Well, if we use this as just a long-winded way of saying that, we can. To substitute in, okay, oops, we have x, which is the same as this. Replace x with all of this stuff, okay, and then we have a plus y equals 2. So what is the y value? There we go, we're substituting. Well, subtract this a number from both sides. This may as well just be number symbol, okay? It's a long name for a simple thing. So I got 2, and then minus this guy. Okay? That's the answer. We know how many each of these symbols is worth, right? And subtracting, we're really adding a negative. I'll leave it like this, it's fine. But notice this is just a combination of our coefficients, the 2's and the 1's here. The 2, we have a 1, a 1, a 2, a 1, a minus 1, and a 2. Those are the A's and B's and C's. Okay? So they all are of this form. So instead of doing all these separate, where you have specific numbers, just leave it like this. These are symbols that represent quantities, just like that. Those are symbols that represent quantities. Just, that's how you do the algebra. Just leave it in this form. Okay, I'll do that one last. In the meantime, I'm going to do some more videos today with different types of coefficients, simply to help you see tricks for arithmetic, because that's really all you're learning here. You're doing arithmetic, okay, because of these symbols. You're not learning algebra. You memorize the steps in algebra to get an answer. Well, once you know what to do, you don't have to think. That's the whole point. So let's see. Next up, let's make it one step harder. What if I gave you a half? And really, I'm going to do my 2 like that. It's important to do 2's like this, especially when we get to 3 variables. Because if there's 3 variables, z comes after y. So just like you don't want to write a y like that, because if you're writing too fast, it's a yex. Write your y like that. this can be mistaken for a 2. So this is your z, and this is a 2. That's how you write them, so you don't accidentally mistake them for one another. Okay, super important. All right, so I don't know if I'm mastering this topic on my own. I'm going to pretend like I know nothing about it. I'm going to create a problem for myself. I could do, I don't know, 2/3. I'm just throwing in the simplest step from no fractions. I'm keeping my numbers as small as I can. 1, 2, 3. Those are the first 3 numbers. And then I'll put, I don't know. You know what, why change? But I'll just leave this one like that, the way it was. So I kept one line, I changed the other line. And I want to solve this. This is my new problem I'm going to do next. 1/2, so the coefficients are 1/2, 2/3, and 1. There's really ones here, but we don't write them. So 1/2, 2/3, and 1. So I'll go here, and I'll go, how do I get my, oh wait, 1/2, 2/3, and then here's where people mess up the most. As far as points, they write the problem down wrong. Step 1, make sure you write the problem down right. So this is a different line. The second one, the blue one, is still the same, but why is this so small? Uh-oh, I broke it. I broke it. Well, hopefully I come back. So you can see these cross at a different spot. They're different lines. This is a question we'll do next, just so you can see how to deal with fractions. All right, so stay tuned for part 2.